Hello everybody, welcome to another stream. How we doing? So last stream we finished off the entity system. You know, we've got a very simple test scene. We'll be re-looking at the entity stuff when we actually need to use it next time. We actually need to use it on a large scale level. But for now, it will do for us making small levels in some small prefab or custom level editor. So the next thing we need to do to get to building like an editor is we need to wait to save and load data. And because we're going to be saving and loading, because we're going to be creating custom like models and things, we got to make sure this data can be preserved for the duration of this development and maybe after, and be upgraded. And the data format can change, but we keep the assets that we've made and stuff like this. So we're now moving on to the decoder/encoder system plan. It says 3 streams here, but it's probably going to be more like 6 streams, and it's probably going to be a stream or 2 of planning. So let's get underway with some of the planning today. I've been thinking about it off stream a little bit. Hey Glorissa, hey there Wujilla, how you guys doing? Welcome guys, happy Sunday to you. Hope you're having a good weekend. So yes, I've got some things I would like to achieve, features. I don't think we'll be able to get all of the features. So I guess let's bring some of these ones in. Let's see if I can. So as you guys know, right, the more features you add, the more complicated the system gets, and that could possibly end up taking away some other features, right? Because you made it impossible to implement some other features. So we've got to be careful with the way we try and tackle some of these problems, but also, yeah. So let's see if I've duplicated any of these. So hard-coded functions. So I think I want to rather put like, I want to put like the reason or the things I want to achieve, and then how I solve it will be like a separate thing. So hard-coded functions. Maybe not. Doing well, working on more Renny Graph shenanigans. Awesome. Very cool. Sounds pretty great. What are you building like an engine, or have you got like a game in mind that you're building this renderer for? So we've already got this sort of text file and binary format thing here. So we've got some questions, right? What do we want to decode/encode? So we wrote this up last stream. So let's just recap it quick. We just want a text format for version control and for development, right? So we can do merging, and we can kind of see what the data is without opening it up in a specialized program, just by opening it up in a text editor. A binary format for release and networking, right, when we send over the network. Because this is going to be more than just encoding data that goes on disk. It also will encode and decode the networking packets probably. That'll be the same sort of system. Since it's just defining a way to take one data structure and compress it down into an array of, or into some stream of bytes. These are the types of things we want to encode, so like level files with entities in there, which come from that entity system, which already has some sort of layout file, a material file, model edit history, a model BVH tree, like an organism with its pieces and procedural bones, and organism template where it's got a bunch of AABBs and a skeleton, a base skeleton, and then some animation stuff which I couldn't be bothered to go into detail on. But this is the type of stuff we want to get, like, save out basically in the editors. So it's just an idea of what we're going to be building this system for. Now, what features do I require, or maybe like what features do we want? Right, not require. So I would like the hard-coded functions for each type and encoder. So we have like 2 functions per type because we've got a text and a binary format. So for improved debugging and to leverage the encoder specifics, so we just had a generalized encoder API. It might be a bit funny to specify like a bit width or like print this out as hexadecimal. Like they're very specific to different encoders. So I'll be leverage them. You know, we actually have quite a few different things we want to encode. So it would be great if it's automated. So I'm probably leaning down the code gen path because we just did the code gen thing for the entities. We made this little file and it generates a whole bunch of code that we're going to be using. So probably going to go down that route again. Stability, when we change things like data types. Sorry, stability when we make changes to data types. So versions, upgrade, notify when I've broken the rules when editing a data type. Ability to make breaking a part of the API and upgrade support. Right. So with this sort of idea is like when you have these file formats, I think that one of the things that I'm not really a big fan of is there's usually some rules. And it would be nice if there was some way that the rules were either quite simple or like there was a system that could check and make sure that I've not busted something. You know, because it is because I can go away and forget about these rules, or someone else comes on the project and doesn't know the rules, and you know, problems can just arise from that. So it'd be good if there's a little system that could check it. What I wanted to add here from today, so we want to have versioning. Yeah, so versions, upgradability. Okay. Maybe I should bring these in. Maybe I should get rid of that line and replace it with what I have here, basically. So there was this one, ability to make breaking changes and start over. So like the networking stuff, might want that. Right, so let's read that new stuff. Upgradability to preserve the data between versions. If wanted, networking might not want it. Yep. Yeah, because we want to update. Like we've got these files that we've built, like assets that we've built. We want to preserve that data going forward. Debuggability. So we might not want type tables, but they might show up. But we don't have the whole encoding system driven by type tables. You know, we want these hard-coded functions because I don't know if you guys have built this sort of stuff before, but if you say sort of like, you know, save strut and you pass in some type information, right? And this function is going to probably call like, you know, save. Why didn't it? It's not got a new line after it. That's why. it maybe calls the save type one, and save type it does a switch statement over all the different types, and maybe it can do like save int, right? And there's like save array as well, right? There's another one where it's like save an array. And what ends up happening is it's just so general that when you want to save like one structure, it's got other structures in there and arrays and more structures, and it's goes down quite deep, and your call stack is just filled with these guys, and it's quite plain. Obviously there's like a data pointer in there or something that goes in there, but so debugging this stuff can be a bit it can be a bit harder, right? Because when you put the breakpoint in that function, you've got to maybe put an if statement in there or something and do a string comparison on a type. Where it's just in a hard-coded functions, it's a little bit easier, and everything's in the right data type. So it should hopefully be easier to debug. That's the hope. Best viewers. I've got to ban this phrase. Hang on a minute. Hey there, Devastated. Welcome, welcome. How's the weekend been? Yes, I've been bad. I've been pretty good. Just went for a walk with my my wife and my son yesterday, and yeah, I need to add more of these. But block terms, right? Trying to allow these guys. They put some stuff on it. Best views on. Right, let's see if that'll do it. We'll try best reason. Right, time out. Right, see how that goes. Doing well. More general renderer. Take in data and spit out the screen. But yes, a game in mind. Awesome. Yeah, I understand because you're building like a GPU of your own graphics library essentially. That's cool. Cool. Yeah, I don't understand what they try to do. Surely the people who click on that website are people watching. I don't understand. I've never really clicked on that link, so I don't know. Also, why not ban him? Get out. Yeah, I knew the bee was not a bee, but I'm hoping it would catch it. That was my hope. I saw it had that little tail under it. Yeah. But I wonder if it's not smart enough for that. Remember there was those ones where it's like, want to be famous or something like that? And they would dress it up in so much UTF-8 stuff, you know? Pretty crazy. Yeah, so it talks about the debuggability thing. Maybe a system to catch user error when it's in data types. I want that. Ability to make a breaking and start over and upgrade support. I've already put that thing there, so it's delete that line. Stability to making changes. Okay, that's cool. Right. So there's another one. This is not something that I need because it's just me working on the project, but in the future, if there's more people working on the project, or maybe whatever, right? It would be good to make sure that this problem is at least maybe possible in the future with a little bit extra work. I don't want to necessarily solve it now. I just want to think about it in the design at least. So that is like branching, like version control branching support. So what does this mean? Well, imagine if you have a strut, and you know, have some fields in here. Maybe it's best drawing it with a bit of Milton, maybe you have some base data structure here. One branch makes one change to that data structure, and another one makes another change to that data structure. And then what happens is later on they get merged. But what you've gone and done in the meantime is both of these separate branches have made changes to a data file, right? Can we at least try to minimize that? And can we try... and is there a way to possibly make it so that some of the data can be upgraded to this merged one? I think this final step, if you want to take the data that's been modified and upgrade it, is probably impossible. But we can at least think about it. But I think we can minimize the problem, though, which we'll get into as we talk about the solutions. You'll see that there's ways to probably minimize it, and we'll go with those ways, I think. But yeah, I think that's the only thing that's going to be problematic with the system that we build, perhaps. We'll see. So, right, should we start talking about maybe what are the core foundations that we're not really going to change? So the core foundations are, we probably have like we're gonna have like a text and a binary serializer. They just have a bunch of functions, and we're making some hard-coded, we're code generating. Maybe I don't need this. Yeah, so I guess let's go and make this sort of like, let's go and sketch out like let's go and sketch out some kind of custom data format, which we're going to be using to solve these problems with, or put these features in, right? So I think we could probably just go with a basic one of like a level, right? And an entity or something. So, we have many entities, many different entity types, but we'll just keep it very basic. So here's going to be the sort of like example of a .enc file. So it would just be like we're defining some C structures, but it's probably going to have some different qualities about it. One, we want to be able to kind of specify like how we're going to format this when we sort of like present it as text. But also we want to specify like how could we help pack it down when it's when it is in binary form. So what I would also like to say is these data structures are not going to be ones that we use at runtime. When we go and save out, we'll convert the runtime data structure into these data structures here. Then we'll have the code that's generated, which takes these data structures and just puts them into the other format. I'm not really wanting to support existing data types or anything, and they just have to go into this system if it wants to be code genned. So I think as a naming scheme, I might call it I think these might have the suffix of enc or something like that. Or maybe data. I've used data in the past. We'll try this one for now. So this is like the encodable data format. So the way we could probably say is that you have an entity. Well, let's use reflection. So we're definitely going to build. I think we're going to build. We're probably going to rely on reflection data for old. All right, okay. We're going to code generate from okay, we're going to read over this, right? And we're going to get all the type information in the code generator. The code generator is probably going to produce proper data types and everything, and produce functions which don't have for loops over type information. I don't want for loops over type information. But we are probably going to have some type tables to read from older versions of the data type, right? But we'll get to that. But yeah, I want to try and avoid type tables as a primary way of doing this, because I think they hinder debuggability and the readability of code as well. But hey there, Sully, how you doing, my friend? How are you doing? Hope you're having a good weekend. Hey, Nick Vorza, it's been a while. What have you been up to? So you can imagine you have your array of entities. So we'll probably support, we'll definitely support some form of arrays. Since this is a custom data format, could we, since we're code generating, let's have a bit of a think about it. So, C has the flexible array member thing. Is that really useful? So, yeah, we won't be, for the binary file, we probably won't be, we're going to actually be like translating the data, so we won't be able to like take a piece of memory and just cast it into a data type and just read that thing. I'm not hoping for that solution because we're going to be supporting versioning things. So I think we should probably, so when you have this sort of flexible array member thing, I don't really see if that's really that useful. Yeah, maybe do the array syntax and get a pointer. See, I wonder if we can like just put that in there, you know what I mean? Just to say that is constrained by that. So when we sort of manufacture this type and then give it to the serializer or the encoder, the code generated looks at the entities field and then does a for loop over all these entities and encodes them or something. Maybe that's the thing we do. I've also got my sort of grow. Yeah, I think that seems sensible. So then you probably have like other things about this. But yeah, let's just say, for instance, what else can we add? Right, so let's say this one has a coordinate. Maybe we can pack these guys down or something. Let's say it's got some health in there as well. Maybe some strength attribute as well as an example. What else can we say about an entity? You want to say it as like a weapon or something? I don't know. What about some floating point number? What can we say about floating point one? Let's say it has some maybe we just call it scale. I don't know, just something called scale. So I think that this should be a good example for what we would like to achieve, or to, for example, what we want to achieve. So we like suffix with encoder or something like this. Right? Okay. So, we need like something to support hexadecimal. What's one that will support hexadecimal? Let's say strength is in hex for some reason. Right. So I think what we want to be able to do is have, if we have like a H whatever, that'll be hexadecimal or something. Or maybe we should... So this would mean like when we encode it using the text encoder, this will know to serialize it out as hexadecimal. Right. There's also some other things as well, like for binary format. We probably want to support, when you say like a U32, maybe you want to be able to say, you know, with a coordinate, the most we'll need is 10 bits. So you say U10, right, times 3. And that's just saying you've got 3 10 bits after each other or something. My concern though is the so you'll be like bit packing stuff directly in, which can be like quite slow, if you will. So that's probably good for networking, but if you're just saving stuff out, it's probably not something you want to do all the time. Maybe, right? I think you get benefit if... Yeah, let's just say, so say if you had the ability to do this, are things in the data structure going to be bit packed, or are they going to actually have some form of alignment? Because, you know, as soon as you start reading data that's bit packed like this, you're going to get the case when you sort of, you know, if you read like 4 bytes, you'll go over those 4 bytes and you have to read another 4 byte or something like that, and then combine the two just to make one field or something, because things won't be aligned anymore. So I'm wondering how... Yeah, 10 bits per axis. Yeah, exactly. So it's just a play on my U32 times 3. Could we just say U10? Right. Could be interesting. But then you get rid of the alignment. So I think this is because I'm wanting to... maybe use it for networking as well. But that networking really wants to do that. But then when we produce data types for this, we're just like when we actually code gen, if we were to do something like this, how is it going to look in the data structure when it's code gen? Maybe we read it up into a U16. But it's only using 10 bits or something, I don't know. It seems a bit silly. So maybe we do this. Yeah. Yeah, I wonder if we want to have stuff that's like aligned. Because if it's aligned, it will be better. You can just read the whole thing in quite easily. I think we'll just do that for now, and then we can extend it for networking later. Because we don't need it for networking yet. And that can just be a future thing that we do. And maybe that can be a different type of thing. We can maybe say this is like a bit strut or something. And that means it doesn't really care about alignment. Maybe. Do you use anything like Pragma Pack in C? Do you want to support that in your compiler? Yeah, so there is that Pragma Pack thing. Yeah, there is that Pragma Pack thing. But yeah, in my HCC compiler for GPU, I don't support that, no. But for this code generator, I don't know. Maybe we could have like a Pragma thing, which then says. How do they do it again in Clang? It's Clang, isn't it? Pragma Pack. And then you sort of. Yeah, I think they put it before the strut, isn't it? Yeah, then you pop it. Yeah, I remember that. Yeah, maybe we can say... It's interesting. Maybe we can have a play on that. But yeah. So I think it would just be better if we can just read and write the plain old types. If we need to bit pack it, we can add that feature later. But I think we want to have a thing called like a H whatever, and that means print out in hex for the text stuff. But what is kind of useful is maybe the binary one, you can maybe support different ranges and things, you know? But again, that's probably to do with the bit packing stuff. Maybe. Yeah, so I was thinking with the integer types, you could probably say, you know, support a range of ints, like a range. And you could probably use that to quantize. I wonder. Yeah, I think I'll just leave it like this, where it's just a mimic. Maybe we can say, maybe rather than having a proper hex type, we'll just have We won't have any special data types for now, but let's just say we want this one as hex. We can just say hash hex like that, right? And maybe you do have to do it before the semicolon, right? So that gives a little directive to say we want hexadecimal for text encoder. Right, so I think this is the basic idea, right? Not too many complicated additions. The only additions we have are extra little attributes like this. And maybe for arrays, you can say, hey, this entity array has a length of this other field. So when we code generate the decode and encode, we can we can use that field basically. If we want to do any more advanced packing, we can always add this later, but for now this will do. So I guess let's slowly start adding, if we go down the features and start adding like solutions to how we're going to solve this. Batman, Rust, no pointer. Right, pointer, good point. We've got to test pointer. So say if we wanted to have an entity which has a parent. That's a good example, isn't it? So if an entity had a parent, you would go something like that, right? So also, can we think about arrays maybe? Where arrays a bit more? Like, so you can have a fixed number in there. Maybe you call this Yes, you have a fixed one, so that's all in line. What else? Yes, see, I don't know if this one will come right away after in memory in the binary serializer or not. You're not really going to have an unsized array, I don't think. It has to be known somehow. So I guess when we use a pointer in this syntax, what it means when it comes to the serializing and deserializing, a pointer just means a pointer to a single element. And if you want a pointer to multiple elements, that is this syntax. So this would be like, you know, your C++ just be like a ref, I guess, right? Yeah, that's cool. But thank you there, Nick Volza. That's a good addition. I would have missed that. So the next one is probably like maybe versioning and for so we make changes. So I've been thinking about this a fair bit. So so if you remember, we got that problem with the version control and branching that we mentioned a second ago, where like you could have some base version of the structure and two people start making changes to the same data structure and they try and commit it. And also, so there's that in mind, but there's also the thing where it's like, the 2 seconds, just open that window a bit more, it's getting warm. I thought it got colder today, but it's very warm in here. Yeah, so if we make So we want to be able to version our data, right? So we could version the structures, but what happens when you have version things like the structures? Then maybe you say like version 0 or whatever, right? You versioned the whole structure. So what happens is when you start merging between different branches and things, is when you version a whole data structure, multiple people are more likely to change the version of a data structure than they are to change the same fields, right? So I think if we version the fields instead, this can lead to less conflict when it comes to sort of different branches. Again, this is not a problem that I'm solving for me now. It's just potentially in the future, if there was going to be more people on the project, it will make sense to have at least think about this problem a little bit. So if we version things like individual fields, there'll be less chance of people accidentally, well, there'll be less chance of people like changing the same field, if you will. So when will you need to actually up a version? I think that's the biggest question. So what happens when you have, okay. How are you going to serialize a pointer? Do you know sustained solutions or like an index or relative pointers, but not more than that? Yeah, see, that's the thing. It's like you can't do it right off, like, because like you could serialize it literally like right after, but then like if you have like an array, it gets a bit crazy. So the better solution might be for pointers. So you might be able to have two different. You might be able to have like a back and forth, a front and back allocator, where you mainly allocate from the front, but then when you go and decode or encode a pointer, you push it from the other side, and then when you get to another pointer or finish that one, you go back the other way. And yeah, so maybe doing that sort of head and tail allocation scheme could be the way to do it. It doesn't have to be head or tail, it could be another parallel allocation. Two linear allocators or something, I don't know. And then they get concatenated to each other in the file, I'm not sure. But yeah, there's ways like that. I think we can do it. Is it starting to get cold in the UK? That temperature is really plummeted in last week here. Yeah, it definitely has plummeted here. But sometimes you get that nice warm end of September as well. It's a bit weird. So when might we need to increment a version? You might be thinking like, well, because like if you change the name, that's like fundamentally a different field, right? Kind of is, isn't it? But yeah, we've got to figure out how we're going to preserve data as well. So I think the main problems arise from when you remove a field. To say we removed health, right? And then we probably have in the binary file or the text file, we'll probably encode some form of type information, right? So the type information is going to have, for the one that's been serialized, so for the piece of data that's been serialized on the disk, it has that health in there, right? But for the one that we are trying to use now, it doesn't have health, but that's fine. You just skip over the health and just don't read it because you don't need it anymore. But then what happens later on if you add it back in? Well, if you add it back in, right, and it's got the same data type, no problem. But the problem arises when you change the data type. Say we need 16 bits instead. So this will mean that we kind of need a bit of intervention here. We need a way to sort of resolve this. And I think we've got a few solutions that we should support. One would be we can increment the version and provide some kind of upgradability. And the other one is increment version, discard. Right, don't upgrade. You know, reuse the default value. And that kind of reminds me, default values. We should maybe have default values like when we load it up. So maybe we say the default value is just 0, but if they want, they could specify something like 100. But I wonder if there's something else to think about with versioning as well. So I think we need to write these things down because they do get really complicated. Where's the music gone? Perhaps encode things like structure of arrays, store components in a sequence, and have entities in a small list of type. Yeah, so I've got an entity, kind of like an entity component system now that I code gen from this file here. So it's probably going to be stored like that anyway. But yeah, it will be done explicitly through this file. I don't want to have anything crazy going on where I do like SOA serialization in this unless made explicitly, I think. Will your serialization have ways to deal with cycles? I'm not sure what you mean by cycle study. Can you define that, please? Also, store all integers in variable length. Yeah, so I did think about doing different sizes of integers, like a different bit width that is not a power of 2. But I've just been thinking about it, and it seems like it adds a bit of complexity, so it's just easier to deal with aligned data for now. And if I want to do any more aggressive packing stuff, I can always just add that later. I don't think we're going to be... Yeah, I think I can add that later. It won't be a problem. So the biggest problem is when it's not when you add or remove stuff, it's when you change like the data type, or you want to reinterpret the data on disk as something that's different, right? So I think the number one rule at the moment is like you have changed a data type. You've changed the data type. So, and then we could probably have another rule where it's like things never get removed, maybe, right? Technically. You can imagine fields are never technically removed. So we can say like a field name is never technically removed. So if you change a data type, so you delete something, bring it back, change the data type, you've got to probably provide some form of different version. So the older version will be stuck around somewhere, and then you have a new version maybe. And so you got to have a way to upgrade it. So it would remember like, oh, the previous one was a U8, but the new one's a U16. So maybe you say, hey, this one is now a version 1. Right? So how do we upgrade this? So we could maybe, when we code generate, we could just generate a function which is literally just called entity enc health v0 v1, right, to v1. And maybe what happens, right, is we get in a pointer to, or we get in the old value and we return the new value, right? And this is all just explicitly called by the code generated code. And then, so it defines the for declaration, and you as the programmer have to implement that upgrade function. So, and remembered by the system, shall we say, right? So, change the data type. The system will error if you try to do this without versioning. And then sort of like, you know, you do the versioning. So you sort of apply versioning, or you increment the version for that field. So you increment the version for that field, and implement the upgrade, right? And then maybe there's a way to also say no upgrade, and then you're probably better off to write like the version number in there. So maybe you say v1 no upgrade, or like, and this is a way to basically say version 1 is a fresh start, we'll take the default value. And then this means it will not define that, right? So you say either implement, you know, I don't like these numbered things, it's just a bit dumb. Right, so either implement the upgrade function in code, right, after the code that's been generated, it's just be a compile error, right, in C, or use the sort of v x no upgrade thing, and that will then mean it won't get one of these sort of things generated, right? That'd be pretty cool, I think. So maybe we'll say, yeah. Right. An example of a cycle would be object A is pointing to B, I see, which points back to A again. Amazing. Yeah, I don't think we'll support that. But we will probably have to bookkeep when we chase pointers. We'll have to keep the address to see if we land back on that same pointer again. It'd be quite easy to write, I guess. But that's a good point. I should write that down. To do, wait. Bookkeep chasing pointers. When encoding, so we don't cycle. Something like that, right? Thank you there, Sully. Yes, I think this is the major sort of problem when you delete stuff. And this means we can individually, when you bring back an old field or if you change the data type. It's mainly the change data type thing. But also, if you don't change the data type, you can manually upgrade the version and just go, you know what, I want to change how these things work. Change this the value that's already been saved out and maybe account for some error in a previous thing that happened. So the other thing is we've got these default values. So if I change a default value, what does that mean, right? Right, I'm just gonna take a quick break and get another drink, and then we'll resume in a sec. Right, welcome back, everyone. Yeah, so we just resolved this where we changed the data type. We're going to be using, like, when we serialize out a file, it's going to pack some type tables in there, just so we can know, like, what fields they had at what versions. Right, so there'll be some type information like this stored in the file, and then this is one we're trying to read back. It's got a version 1 on it, whereas the other one was version 0. Maybe we should always require a version thing on it. I don't know. But yeah, you can also mark it with like a no upgrade, so you don't need an upgrade function. But if not, you'll get the upgrade function. So the other problem is that if you have a default value and you change it, right, does that impact things? It doesn't, right? Because the default value is like, well, the health field was missing. So it doesn't really affect the binary that you save out, maybe, because what the default value allows you to do is omit the field in the serialized data, maybe, but if we don't omit it and it is put in there, then the default value has an effect on, the default value will have an effect on the binary file that you produce, so it will need a version upgrade. So default value of 0. No. I think you always have to put it in there, because if it's like a binary file and you check if the value is not, is 0, therefore don't put it in, it's going to be every piece of data you have to say which fields exist and don't exist, and that is just extra stuff to put in there, I think. So we're going to encode the value in there. So it means if you change the default value, you're going to need change a default, data type or default value, then you have to go through this process. That sounds fair. So if you say print out as hexadecimal or print out as decimal, that's obviously going to be fine because it's the same value at the end of the day. Yep. So I guess what happens if Right, I think that solves that problem. So you still have that problem when you've got the branching. So say if you have two people working on the project and they both edit the same data structure, this system makes it such that it's okay so long as they don't edit the same field, right? So I think if they edit the same field and then they try and merge it back in, and say they've already like produced data with it, I think there could just be a rule where like if you end up making a change to the data format or something, you can't, it has to be merged back into the main branch before you start making content with it, if you will. And I think that might be some rule we have to do. But say if they edit the same field, say if they don't edit the same field, it's perfectly okay, right? Because you would have produced, imagine you have produced data, and you have reflection information in the saved out binary. So maybe they made another thing called like defense, right? So with defense, this is not in here, but another branch added the defense field. Well, we don't care about the defense field clearly, right? At this point, so we won't read it in. But I think say if they had a version 2 and you have a version 1, say if they have a v2 and we actually have it but with a v1 version, that would mean we're trying to load data that's too new. So that would, I don't think we want to downgrade data, right? That's just, I don't think we're ever going to get into this thing. So we should probably have, there's another type of rule or something where if you try and load, so loading old data, loading newer data will result in a error. So it will be completely okay if the new data doesn't have newer, loading newer versioned data will result in an error. But say if they just added fields that you didn't have, that would just work, because we'll just skip over them. But yeah, I'm not really fussed about loading newer files on an old version. It just doesn't really, it's not really a thing that we should try and solve, right? Because if not, we're going to make a downgrade function. It's just pointless. Right, anything else that we could solve with this? Yeah, I think we're in quite a good place. Um, so if they, hmm. Yeah, I can't seem to think of any other sort of issues. If anyone has any scenarios that you think the system will fall over, feel free to present them, please. But I think that's okay. So I might, for the time being, um, yeah, I might try. I might have a think about maybe the whole packing stuff now, just to fit it all in the initial design, maybe. But we can always add it later with the versioning system. No, I'm not fussed about that. Just thinking. Um, yeah. Maybe we can start writing out some example code for now. So the example code would be example code gen. Right, we're going to have type tables. It's just going to be a thing. But that's only to serialize out to the file and then read back in as a way to sort of understand how you're decoding an array of bytes. Nothing more. Remember John Blow saying that this serialization didn't store the default values but substitutes newest one in at loading time. Newest one. Right. Yeah, I remember your system is just mem copy the thing in. Yeah, it's not a bad idea, right? If you it's quite a cool solution. So just have a yeah. Yeah, yeah. Substitute the latest one in, yeah. It's interesting. So the thing is like if you change the default value, yeah, do you need a version upgrade then maybe? Maybe you don't. Because it's just a default value, isn't it? So if they put the default value in there though, I've got to put extra bits in somewhere, isn't it? But then again, 0 is default for everything else implicitly. So maybe we always pack at the beginning of every data structure, we always pack a bit set. Right, it'll be U8 if you only have 8 fields or less, but then it'll be U16. Yeah, maybe we'll do that. I think that does sound quite sensible. Yeah, I'll convince myself. It sounds like a good idea. So I guess we want to say 0 is the default value. So this will mean that we can yeah, possibly save memory then. 0 is the default value unless specified explicitly. Default values are not stored, but instead, so in the binary file, it'll be a bit set. A binary file will contain a bit set. See, say if the whole entity is a default value, then you don't want to have elements of the array just be missing. Seems a bit silly because then you can't do the well, you'd be unpacking it linearly, right? Default values are not stored. A binary file will contain a bit set for each field. A bit set to say which fields exist. Which fields are not the default value. Yeah, we'll think about that. The other one, if the whole strut is the default value, what do we do? I don't know, but I finally fixed whatever I messed up with my memory structure in my render graph. Now works as intended. Awesome. Pretty cool. So what features does your render graph have? Is it still the sync code stuff? So say if you had an array of this, right? Well, we know if it's a strut, the first bit of data in there is yeah, but it works automatically, right? The first, if it is an array of a structure, the first implicit field would be a bit set. So you just read that bit set anyway, and then unpack it. So I don't think we need to do anything special with arrays. Arrays can't have default values. So we've got to remember that, right? Arrays and pointers cannot have default value. So wait, can arrays have default values? Yeah. Arrays and struts cannot have default values themselves. Cool. Media mode, no reordering, awesome. No merging, awesome. We'll trim on these passes. Insert pipeline errors as needed. Cool. Yeah, sweet. Yeah, define them explicitly is a bit difficult. Yeah, so what other things can we do? So in a code gen. See, we'll probably have a sort of like so we have this binary encoder / decoder. Right. So there will be some kind of type information. So we do have to build these type tables. But this is only to be stored within the file, so that we can read data and understand it. So we probably want to have some type. So enc type. And you probably have a type kind. So the type kind will probably describe, like, oh, is it a... How do you uppercase in Helix? Have I never done that? I'm confused. Wait, there's a search for in there. What? Switch to uppercase. Control tick. No, alt tick, and then it's just tick. Ah, yes, I remember. Shift tick. There we go. Cool. Right, egg type, kind, U8, right, and you obviously repeat them all. You know, we could just say int, and then it's got a number of bits. Right, so basically we have this thing, right? We know what it looks like. So you got the kind in here. Then you probably have like so this is the type of information that you store within the file. You probably want to have like some form of we don't want to probably store the names of the data because you know, it means people can just read your binary files and know what's in there, right? So you probably store a bunch of like yeah, you'll probably have a name hash or something instead. So you just have a hash of the name. Or I could probably calculate those or something like that. Yeah, the checksum will definitely go in the binary file at the end. That's a good point though, the Negvorza. That'd be the binary file at the end. This is the type table. So the name of the type, you then want like the actual data of the type will probably be in like a union or something. So you probably read out you could probably have like a U64 for a uint, an S64 for a signed int, then a floating point. Wait, sorry, that's the actual value itself. All right, what I mean is you need the structure type. That's what I meant. So for a strut type information, array type information, and then what else? I think that's basically it. Oh no, there'll probably be a... No, that's it. Yeah. So we'll probably have some kind of like strut type. So the strut type is going to have an array of fields. And it's probably going to have its own... Well, the name will be within that type thing, maybe. Maybe we don't... Yeah, maybe the name is in a different place. I'm not sure. So there'll be an array of fields. And there'll be a fields count. There's probably not going to be much else for that one. But then in the member... So for the field, this is where it does that versioning thing. So we'll definitely have like a version number. We'll have a name hash. because you want to say, like, for your current, you want to be able to look over all those fields or whatever, find the name hash, which makes sense. Maybe the name hashes will be here. So you'll scan over the name hashes, see if the strength field exists, for instance. If it does, get the offset for it, and look at the version. So the field name hashes will probably be in here, like that. Yeah. And then we need the data type as well. So that'd be an enc type. Right. So I think that shall do. Wait, there's a default value as well, isn't there? So if you have a default value, it has to be a primitive type to do that. So it will probably fit within a U64. Probably. Well, you might have a vector thing. These vector things are actually kind of data structures, though. Right, so arrays. So maybe the way we should say it is instances of encoding structures or whatever cannot have default values themselves. Other encoder data types, but the ones which are kind of outside of the system, those might be able to support default default structures and things like this, maybe. So the default value would probably just be the void pointer to the default value and maybe a size. Or maybe the size is derived from this thing. Maybe we put the size in a line in here. But when does the align matter when you're going through an array of bytes or whatever? It would. Yeah, I think that's something to think about. Because the hope was, by not doing this special bit packing thing, you would just read the full type back out, right? Makes that code a little bit easier. But then say if we have these optional default, so say we have these default values, and if the values default don't encode the field, right? Or you've put a 4-byte or a 1-byte thing down to say which fields have the default value or not. So with that, see, an offset doesn't make that much sense anymore, does it? Because you have that thing in there. So you would go over the So when you deserialize, you'll probably say you might initialize the structure with its default values, and then after you've done that, you run over all of the fields for the ones that exist, decode those, right, and then set them in that data structure. So that might be the way we deserialize. In binary format, maybe compressed, like PDF did. Huh. What do you mean? It stores like other compressed assets in there? Is that what you're saying? Yes, maybe when we decode, we initialize the structure with its default values. Or initialize default values, then process the bit set and decode the values that exist. So that means we don't really need an offset anymore, or the offset doesn't make sense, just the version. And that can just be checked at the beginning. Right, and there's a default. Why would you store a default value in the type information? You don't, you always load it with the newest one, so you don't need that either. So all you're left with is the type and the version, and that's all just checked. That is all just checked at boot, not at boot, when you first open up the file, just to make sure everything's all intact, and then you can go full ham on the thing. Yeah, that makes sense. That's cool. Compressed string, for example. Or like a compressed... Well, something we haven't done is string support, but I see what you're saying, like a compressed array of bytes, right? Just an opaque array of bytes. I think we can already support that like an array, where you just say, you know, you've got your compressed data size, and you just have your compressed data, and then when you, you just got it stored in the file. We can always do stuff like that. But you're right, we're not done strings. Yeah, something to think about is strings. So the array type so this is only the type information that we store in there to do the validity checking, right? Do we need to verify array types? I don't think we need to verify array types. Do we? Maybe. Right. So if this changes, oh, that's interesting. So we've also got that pointer type as well. Don't forget that one. Right, so where was we? Yes, the array types. So if you have an array of entities, and you put like the count in there or whatever. When you open up a file that's already been serialized in the past and you read the type information, what you're looking to verify is that the size has not changed and the data type is the same, right? But you would already know if the data type is the same. Well, no, you wouldn't. That's the whole point of checking this. So inside the array, we need to know the element data type. So you have the element data type. Then you also have the number of elements. Now the number of elements could also be bound by a so you can have an array size, an element, or an elements count. It could be fixed, or if this is 0, right? 0 means if it's 0, then you get it from a field, and the field always has to come before. Has to be processed before this data type. That's another thing as well, is arrays. 6 arrays, variable length arrays. I guess we've just got VLAs. Variable length arrays. Field must, field with its count, must come before. Sweet. That'll be sweet. So array type, and then if not, you've got the name hash. Variable length array name hash. That is, so we can scan over the data we've already scanned or something, and then pick it up and then know how many elements are there. Yes, when we're decoding, yeah, so at the start of when we look at the type information and compare it, obviously that if this is 0 and VLA name hash is different, then we've got there's an inconsistency there. So I'm thinking it might be beneficial to store the names for debugging, because like, if not, it's just gonna be a bunch of random stuff, isn't it, really? So we should probably store the actual name, which get omitted in final builds or whatever, right? Hey there, SNDS, how's it going? So we probably want to say, like, you know, the type information that's stored in binary files. Wait, it's binary. That's the release stuff. Binary files only store the name hashes, but the string files store in the type information. Right? So yeah, I think we will store string versions. Yeah. Just be nicer, wouldn't it? VLA name. Right. Yeah, so is the array data type the only type when we're serializing? Do we need to know Well, no, because the fields have this default value thing, is that right? No, 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 no. The default value is whatever it is. Ah. So when we're deserializing, we'll need some context where we need to sort of know like, oh no, no, sorry. It's initialized with the default values, so we don't have to care about those. Right, so when we're decoding, we still have to know the type that we're decoding in the decoder. But when we have an array type, now when we have a structure that has an array type, which has a variable length array, no, we don't. This type of information is only just used to verify. Wait, or do we? Yes, so when we encode, it's fine, it's all code generated. But when we decode, we could probably store the VLA stuff after the bit set. So we store the... if you store them in order after the bit set, no, it's fine. So when we write that, so I think it's right out of the code, it'd be easier to imagine. So say if we're saying decode, the binary version of level enc, right? So the output is going to be this guy. Hey there, Elwood, how's it going? Hey there, Peachy. Welcome, guys. Good day. Hey, how are you? This is the one this are out, right? And we'll probably have like a, binary decoder. So the basic idea is when you read and put in the out entities, whatever, you'll say binary encoder or binary decoder read U32, right? And you pass in the decoder, it reads the U32, puts it in there. This is all like code generated code, by the way. And then now we have that. Now we can do the for loop. I think there's a bit of a problem. So this is because the VLA fields are the same. We can do this, right? But what happens if the field was different? Yes, you can't rename fields with this system either. This is two problems I think we're running into. One, you can't rename fields. And so let's write this down quick. So can we rename fields? That'd be interesting. Can you maybe specify... Let's put a few questions down. Can we rename fields and retain values? If you change the encoder VLA field to a different one, so say we introduce a new field, or maybe the old data had a different field for some reason. Do we just... how do we handle that? Like we could just say like, well, these are now not compatible, so you need a version thing. But then you got to upgrade. And also, how do we version arrays? Yeah, versioning arrays would be different. Right, there's a whole bunch of questions I've just come up with. So how do we handle that problem? We also don't forget string types as well. We don't want to forget. Right, okay, so say if we have a different variable length array name that it was using before. You know, we know like now we want to decode hmm. Yeah, so here you're probably going to have to pass in like the name hash or something, right? Where you're saying, hey, binary decoder, decode right, and now maybe like hash it up and look for the thing, but you're probably better off passing in the name hash or something. So it looks in the data type enc type. So this is the type of the thing we're trying to decode from the file, from the source file. So we'll probably pass in that source type, and then we're probably saying, you know, grab me that field. So it will look through the type information, through the strut, because this will be a strut. We could probably explicitly call this like a strut. Type. It will look through. Will it? So if it's a default value, we'll see the logic I had earlier. We'll just say we default the whole thing. We initialize the thing to a default value. So maybe we put some if statements in here and just say if binary decoder field exists, right? So we do decoder, and maybe we put in a string. I don't know. I'm being a bit careful about these strings because, yeah, there'll probably just be some sort of like, you know, field hash. Yeah, there'll probably be a pre-hashed string or something, but for now we'll just put strings in there. So we're saying if the field exists, actually decode it, but the whole thing is going to be default initialized to its default value, right? So maybe there'll be a function for it. Level length default value, something like this, right? Then we say if the field exists, decode, but then you kind of got to know like the offset of it, right? So you could probably just say find field. Field offset. Hey Alex, how's it going? How you guys doing? What you guys been up to? Hope your weekend's doing good. It's important to keep the order of the fields. Yeah. See, this is where it's becoming like, if I find the field every time, it's okay. But it does add a bit of overhead to sort of like search for the field, every field. But yeah, maybe you pass the pointer into it. It's a little bit bizarre. So you don't have to keep doing this. Because this, you say if field exists type of thing. So you say read if exists, and you pass in the destination slot here. So you'll go address of out entities count, right? And then with that solution, it can do the find and return early. Hey, Joe Stay, may I ask, what do you work on during the day? I just, the most I can speak about on that is do 3D graphics programming. My job title is my job title is probably an engine programmer, but I'm on the graphics team. So I just do 3D graphics for a game that we're working on. That's the most I can say. Because that's all that's been publicly said. Good, got our first uni assignment. So making progress on that, awesome. Cool. What area is that in? Do you also use Rust? No. C++. C++ will work. About it. You know. But it's very much C-like. C++, although there is C. It kind of varies across the code base, so because there's a whole bunch of people on the different teams programming. Yeah, we're probably sure on all this. This is just sort of me thinking about how I want the code to be, just structurally. So if we can, so default initialize, this now goes. So you say read if it exists, it's a U32, and I'm reading this thing. This is the source type, but we all know what the final data type is because it's code generated. So then here we can go over all the data types and then just do the sort of decode binary. You know, this should probably just be called like binary decode, right? And then we'll probably have another one where it goes over all of the entities as an example, right? Just example code. You pass in the decoder, you pass in the source data type. This one will be you've got to somehow get the, so if it's an array, you could probably get the strut type somehow. This would be the source type for the entity. And we'll initialize that somehow, but we basically go through that source type thing and fish it out. But it's all code gen, so we can easily do that. Then we need to pass in an out to it. So we go out, entities, index, something like that, right? Now things can fail. So I think I might... Wait, can things fail? No, things will fail at the beginning. They never fail while you're decoding. They only fail when you read the type information and notice incompatibilities. So I think this will do for now. Obviously, it will have iteration on it, but I've got some other questions to answer, or you to answer first. So what happens if we, for an array, obviously changing data type is a problem that requires versioning. But if we change the name of, say if we change this, say if we go, say we change the field, or maybe we change it from one which is a field to a, that is changing the data type, isn't it? Right? And say if this is for some reason got a different name. I don't know why you'd do this. Say if the name changes, someone's like, you know, I don't like plural. I like non-plural, so they're going to change the name. Maybe that's classed as a rename, but let's think about it as if it's not a rename for some reason. It's a different field. When we... So in the future now we'll be using this one instead. But what you really want is a function which can know based on the See, maybe it doesn't have to be before. Maybe you could instead say, you know, get the count, entities count. And maybe the way you get this is you say read defaults to 0, or whatever the default value is. Oh, this gets a bit sticky, I think. So maybe you say read if exists, and you just do it again. No. You wouldn't have to again because it's already here. No, you're doing whatever the source one is. So it's like... So it's like an array type. And you get that somehow, and then you say read if exists. So I'm wondering if we want this complexity or not. I don't think we do. So you would then have to say, you know, whatever that VLA name is or whatever, or maybe there's a specific function which just goes binary decoder array count. And you pass in the decoder, the source type of the data structure, and the array that you're trying to decode, which is just called entities. And this will automatically do that for you and that for you in there. And it returns the entities count. So this would then mean you could technically use one with a different name, a different VLA name, because you're loading it from the source one always, no matter if you've manually initialized it here. But then this one would then be 0, or whatever the default value is, and then it wouldn't work. So I think, right, so I think if the VLA name is different, you've maybe buggered it up unless it's specifically a renamed field, which has still got a question around if we wanted to support renames or not. So we'll look into renames next, but we're leaning down. They have to match. Yeah, we'll probably have an alias or a rename, yeah. Something like that, yeah. I like Rust. I remember working in C++ a long time ago. Once 15 years back, remember I used recently used Python, JavaScript, Java, and Rust. So far, like Python and Rust. Cool. Fair play. That's cool. Yeah, I did. I came from JavaScript, went to C++, then C, then Rust, then back to C. So, yeah, I did a bit of language hopping, but I really liked the lower levels and stayed around there. And I programmed in Rust for the sort of a newer, lower level language for a fair bit. But yeah, I think Rust is great for folks who want to come down from higher level languages and learn the sort of more lower level stuff. But I don't think it's a good replacement for C. It's a good replacement for C++, I think. So if we rename fields, say if we renamed it from entities, maybe we do like a rename. Hey, Elwood. I give out a try. Fair play. That's cool, my friend. You have a good evening, yeah, and have a good start to your work week. I'll see you in a future one. Thank you for popping by. So you can maybe say renamed, right? From entities count. Or maybe you have the field left over, I don't know. Let's think about this. Like, I think we're going to have a system which retains the old information. So I don't think you need to, say if you keep renaming it, I think it could retain that information. So you don't have to keep saying, storing a bunch of renamed stuff and it goes off into infinity. It's just the first time when you generate it, maybe. But let's think about renaming stuff, if that's the thing. What would it do? What will we have to do to support that? So in a decode function, right? When you try and look up entity count, you have to say, hang on a minute. Does its aliases exist? Right. Or see, I wondered how this works with versions as well, It just gets a bit weird. Like having like a rename thing. Because if you have right, so let's just think about it without versions first. So if we rename a thing, we'll have to say, well, we're trying to look. You might have to do both, right? And then maybe you do the newest one first. Like you would have already checked. You would have already checked the type information at the start when you load the binary up and start to decode. But you're kind of deep down in code that's been generated. So we want to make it like I want to make it like read more as much as straightforward as possible. You know, maybe there could be an enum that gets produced and you just have a way to look up the name hash for the one you're supposed to look at, and that's already pre-calculated. So you could support renaming that way, where you have in the encoder or something, or decoder I meant, you have somewhere in there stored for the level or this in the source type, you have a way to look up with the enum like what is the name of this field in, I don't know, maybe you say like name from enum and it's just like level encoder entities count, right? It gets a bit weird, but you can look it up and you don't have to worry about, like, that renaming process will be resolved when you first start to decode the whole binary, and then things become like a little bit of a lookup. But yeah, I don't think we'll be using strings anyway. I think what we would have been using is like constants. So now the constants are being replaced, like constants to a hash, like a name hash or something. But now the constants will just be replaced with like some lookup thing. But maybe you don't need the lookup thing because you've already got the source type being passed in. So what you're saying is just pass in the enum that you're trying to decode, right? And then that could probably be stored in the source type or something. So maybe we can support like a rename that way. That's possible. So the other thing about renames is versioning, right? Say if you had previously had this, it was a U16, right? But then it got versioned up to a version 1 and it became a U32. I didn't quite have the foresight, you know, to predict that, so then I versioned it 1 up to a U32. So we need to define the remapping thing. Yeah, maybe we can have a hash extend as well. Or vx extend, and the extend will basically just like, you know, we don't have to write an explicit upgrade function. We can just say like v1 extend. Or upgrade extend or something. I forget these. I don't know what I want to do. Upgrade, maybe upgrade none to be no upgrade. Yeah, stuff like that. Right, so Okay, so say if you did these and then you was like, right, now I just want to rename it. So what you then find out is that so because you've said I'm renaming it from this, when you first load up the binary file, it's got the type information which says we have an entities down here at version 0, right? So because it was at version 0, you now like, and we know we renamed from this. I guess we're going to store this information in the information is just stored elsewhere. Basically, we'll retain it. So we'll know now that we've renamed this entities count last got to a v1. So the latest one is a v1, and we're trying to load one which is like a v0. So then it will call the upgrade, and it should just work fine, right? So I guess the question is then, so that could work. Then what happens if you version this? Well, in the future we can say this just gets retained. So that's cool. That just gets retained, so we don't have to keep that hash renamed around. And then we say we do a v1 of this. What does that mean? Well, a rename from the other one maybe has to be version 0, perhaps, or you can't version 1 a rename. See, renames really start to add a lot of complexity, and I don't know if we should have these. Because you could also then rename it back, right? The possibilities just become endless, and you just have to solve them all. Okay, they're maybe not endless, but yeah. It gets a bit weird. So then if you have a v1 and you upgrade it from an entity count v0, then you basically have to chain through and go, we've loaded an entities count v0, we upgrade it to a v1, right? Then we upgrade it from an entities count v1 to an entity count v1. Right, that's okay. So we had that thing as well where if you try and load, see, I think another problem is, see, maybe we should just make them an alias for each other rather than doing like a rename and forget. Maybe we should just do the alias thing, and if we do the alias thing, then it just they become interchangeable for each other, and they're set in stone. Yeah, so you can just create aliases. I think that's the way of saying it. And then that's the way you do the rename, is you create the alias. And then we'll use the new one. Yeah, so then that all that means that we have is when you do a lookup, whenever you try and look for a field, though this is the problem. No, that's fine. So if you have as an alias, you will have the aliases in memory on your code gen side. When you load the binary file, you're going to have the type information that's currently been serialized into that file. You can then look over all the aliases for that to see if they exist, and then just use that one. and then you respect the same versioning system that's always happened. Because if not, you start getting really weird if the versioning differs between the renames. So I think we'll go with an alias solution, because then that means so I guess we'll add another thing. See, I kind of forgot what this list was meant to be. This list was like meant to be, like certain rules to follow as a user, but then it just become a list of things that I need to remember to implement. But anyway, this is fine. So this one is we support hash alias. Hash alias to rename. So it's kind of like a rename that. Okay, so we do not support renaming, but we do support hash alias to refer to something in a new way with a new name. So this kind of piggybacks on the first rule. A field is never technically removed. It's remembered by the system. So that's how that one fits in with that rule. So that's good. I do like that. That's great. Okay. So I think that solves a lot of problems. We can then use this sort of like enum, and the enum can then look up. So we have to change this structure stuff now. So we're going to have like aliases. So you can have alias. It's a little bit bizarre. So you probably also want to be able to alias structures as well. So put that write that one down as the next one to do. So for the fields, right, you've got like, we had that sort of array of name hashes. So when we have this, so I guess this structure is the type information that we've read from the disk. So when we have the aliases, we're trying to, oh, this would be amazing. So we'll have a verify function, and it'll be codegent. So this can just look for the aliases and just set everything up. So we say verify or validate, and this will return a Boolean, and maybe with some kind of error code or something, or maybe the error is pushed on somewhere else. I don't know. That's a future problem to solve when we actually implement it. So this is just going to validate the source type that we've read from that file, and this is just going to say like this is going to say source type, and so in the source type is a strut type. Yeah, so if we use an enum, it means we can just keep looking up into something, and this will give us a field. So we can have an array of fields initially, and then when you validate it, you are essentially we can maybe allocate another one, which is called the is this we could do pointers to pointers, or we could just remake this array or something. If we did pointers to pointers, it would be a bit weird though, in ways. So when we validate, we could rewrite the fields array, but instead use a lookup table. I don't know if we'll ever need to iterate over the array of fields ever, if we have this enum system. Like maybe we just say like fields So we'll scan over using those name hashes. Ooh. I wonder if we should produce another. Hmm. So that would go now. And you just use that since we've got the aliasing support. I think alias create names. I think alias create name conflicts because names are mutually exclusive between fields on all versions. Bum bum bum. Right, so what you're saying is if you have, yeah, so say if between all versions. Yeah, but you're loading, so we don't really support, so I think with this system, we don't want to support loading newer data with an older version, right? We do kind of support it, but it's not really a thing that we support, right? So if the field is missing, then we're just going to load the default value, which would be 0, and then it won't do anything. I guess. Yeah, that's just to do with renaming anyway. Yes, all aliases will do is take up your possibilities of giving things certain names. But they will join. But we already have that problem anyway. When you take a field, like fields are always retained. So if you delete a field, it will be there forever. Possibly. Because you always have a chance of loading that data again. Yeah, so it just pollutes the name space, if you will, right? So it should be okay. Unless I'm misunderstanding what you're saying, Negvoza, then please rephrase it. Yeah, so we basically, when we're decoding fields, all we need to be using is an enum to look up the field. So yeah, this here would perform the lookup. So we'll be like source type fields, and then we might just index it with level enc entities, right? Whatever the enum is ended up being called in the end. So when we validate, maybe what we do is we simply so we take this would be the new fields array, strut fields, because I don't think we're going to need it. Strut field, this would be the new fields, and it's zeroed somehow, right? Let's just core alloc whatever array of blah 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 blah. So they'll use some custom allocator or whatever. Then at the end of the day, we're going to store in the fields thing the, let's just do a new one. And this will be the enum to fields map. So this is initialized at validation time. Let's call it a map. Boom. Right. So here we're going to validate, make sure we can find all the aliases for every single one of those enums that we've got. And I think I'll just maybe hard code it. We'll just say something like if, because it's all code gen anyway. So we might just say strut field exists, and this could do the aliasing thing as well. So we say if the field does not exist, source type, then the name for it, which will probably be a constant for a pre-hashed value, but for now we'll just put a string in there. Right, it's just me to optimize it later. We'll make sure you write the code. So it'll be like a names count or whatever. If that one doesn't exist, we're going to return false, and maybe we'll push on some kind of error here. Right. To do push on some error. Maybe a better error, maybe a nicer error. Or something like that, I don't know. Or maybe, yeah, we'll see. So then this would then go right, we've found it, and it's called we found the field, so maybe it's just a pointer actually. Buggered that one up really. Yeah, so we're like found field, like that. And then we can do aliases that way as well. Cool, then you would say map, then with the enum, level and entities found field. Now, so you just do that repeatedly for every field that we've got, and that will validate everything. And there'll be some other things as well, like is the version right and all this. Cool. So there's also other problems. Let's quickly double check like how we would offset this binary file. Like a text one is fine, right? We'll know how to do that. So when it's saying read if it exists, sorry, we might have a remapping table which will take you to the which will remap this to a field index. So enum to field index. And we already use it to index this field thing, maybe. We're going to use it to look at the bit set. And then we can use the bit set to work out the offset into the... yeah, into the binary file or something. We can probably initialize these things as well. See, that's another thing as well, like if we have these sort of optional fields and there's this bit set at the beginning of every strut to tell you which ones exist, to work out the offset, you've got to go, right, get me the field index, then do the bit set count or whatever over the ones that exist, then do a for loop over all of the ones that don't exist or whatever. Or, yeah, that don't exist. Yeah, do a for loop over all of them. All the fields. Okay, restart that. So to get the offset, when you have the field index, you have to iterate over all the fields. So it'd be this one here. Get the type. Okay, you just have an offset. No, you'd have to get the type and then skip the size if the field actually exists there. Ugh. Sounds quite, it sounds like quite more of a heavier decode process when we start doing these sort of default value things, right? Sounds pretty. I would have to keep iterating over these fields, get their size to do some offsets and things. We can maybe store the size directly in here. Like the size in bytes maybe, rather than in the type. But maybe store an array of field sizes and it's, yeah. When did I start using Helix? A few weeks ago. Is field name hashes treated like a UID and the same in all versions? Yes. So it'll probably just be like, I got to settle on a hashing algorithm. It'll probably just be FNV hash 64. I don't know if we'll do anything more complicated than that one. If anyone's got any better ideas for a hashing algorithm, let me know. But it'll basically just be consistent, and we won't be able to change it. And if you get a collision, we'll have to somehow. You shouldn't get a collision though, but it's possible. Yeah, so my main concern is this decode process. It just seems like a bit too much. Like, for every single field you want to decode in a structure, you have to look over all of the strut fields and keep adding based on. So for every field you want to decode, you have to scan the bit set. For the ones that exist, offset. But it could be nicely packed in cache, right? We can have another array where you just have the field sizes just all stored in there, and we can, they can just be a U32 or whatever. So it's all just cached in there. That's always a thing. I guess so. Then it allows us to sort of compress the data down, right, in some way. But if we're doing this, we might as well be doing like bit packing as well. But I'll leave that one till a bit later. I guess this is the way we'll do it, right? We'll just, every time we try to look for a field, check if it exists. If it exists, work out the offset by doing the scan over the sizes of the previous elements. Yeah, it's possible. It just adds a little bit more complexity to the process of decoding values, but it's cached. So that's a thing we can do. What's one of the next questions now? Aliases for structures. So we could do the same thing, right? I don't like the name entity anymore. I want it to be called ent. Or you just alias the old name. And then when you've ran the code generator, it will remember and then you basically just it will remember, and then you basically just delete it, right? So I guess we'll support that. Works for fields, the structure types and structure fields. And then we can say hash alias can be removed once a successful encoder generator has ran. Once has ran successfully. Because we will remember that in some kind of text database of the past or something. So we can alias structures, right? That's cool. Yeah, so I was talking about this variable length array thing. Did I not write that one down? If it's not like an alias or whatever, if the like this cannot change, right? And if it does change, the type is fundamentally different. I should write that down. This one, it doesn't have to come before the array anymore. We've solved that problem. You can work out the offset. So we can say, as part of change data type, variable length array, variable length array rename or with different name, not aliased, counts as a new as a data type change. And therefore you have to do this versioning thing, right? So then that gets us down to the versioning stuff. Like, do you have to version arrays? So if I change this to be like, you know what, we're just gonna have 7 entities always. Like, and then we like, so then we go, okay, this has to be then a v1. So then the way this will probably work, so we might not use these sort of things, we'll probably do pointers. And maybe, can they always convert successfully? That's another question. Maybe we have an out value. Let's put the old one in. So destination source type of thing or something. Just take in as pointers so the prototype is basically the same. DST and then a source. So my thinking is like, if we support arrays, so it'd be like, oh, we've done this sort of like entities thing that has had an upgrade and it's an array. So this one will need to, do you need like an old or like a count or something? No, you need an old count and a new count. No, you just need an old count. So number of elements in the source, and then we'll know like, oh, the new one has less elements. Entity inc. So you'd have to somehow do that. Well, could we maybe automate this? What language is this? Well, it's a custom description format for data, and then we're going to write a parser for it, code gen C code. So the game is written in C. Everything's written in C actually. Yeah, so we'll just be generating C code and stuff like that. So I guess if we changed it to another sort of like, or if we changed it from a 7 to a typed 1, how would you know how to upgrade it? Well, it'd be set to 7, wouldn't it? So if the field doesn't exist and it came from like a 7, and then you was like, I need to make it variable now. A variable length array. So you've done the version thing. You know, you'll need to somehow fill that one. Yeah, that kind of makes this a little bit strange here. So we've got two. So I think this could maybe be automated if it's because the two types are known. It's basically just no. So we've got two problems, right? You change the size, or maybe there's a few we've got to solve, right? So you change the size of the array. Array size, fixed size arrays change. Has changed. So you change it from like 3 to 7 or something. Oh, all right. There's another one where it's like, well, we've changed from a fixed sized array to that variable length array. And then the final one is the other way around. Variable length array to a fixed sized array. So these are the problems we have to solve with the decoder. And how we, yeah. And if we're going to support this basically, because if not, the other solution is that you basically, all that data dies, right? So we kind of want to try and have ways of making sure we can keep data around even when we change things about the system. So we should definitely try and support this, but it seems like a little bit complicated with these 3 different possibilities. Which IDE am I using? I'm using a text editor called Helix. It's written in Rust for all those Rust people out there who like a bit of Rust. It's basically like a Vim, a modern day Vim. It's quite nice. It comes built in with a bunch of features out of the box. I quite like it. It's got like a handful of things which I hope they would have implemented by now, but it comes built in with like a language server protocol and a way to search through files, a bit like Telescope in Vim, which is made by TJ. It comes built in with a whole bunch of things, like a way to search through the command palettes. If you forget the key, you can be like, how do I uppercase stuff? And it just tells you. So it's pretty cool, pretty good. I do like the additions and the config file is also dead simple too. It's not a programming language, it's just a config file. So that's kind of cool. But yeah, I'm just going to take a quick break and replenish the water supply. But yeah, then we'll fix this problem and then we'll move on to some other questions we have about, we'll just carry on with the plan. Right, BRB. Alright, welcome back everybody. Why is the camera out of focus a bit? Bit bizarre. Has it always been out of focus? You're saying good. Or is it just... No, maybe it's blurry, isn't it? Because it's scaled differently? Might be to do the scaling. I'll check it off stream. Anyways, yeah, so I want to try and like do this sort of like upgrading individual arrays or things. Like, you know, I was thinking maybe this problem is the nature of the fact that we're putting versions on every single field, right? Yeah. So the reason why we're doing versions on every field is because, well, there's maybe multiple reasons, but let's just double check it. It's mainly just because in the future, if we did multiple branches, it would reduce the amount of like, it would reduce the amount of conflicts that you would get if people edit these formats, right? But if we put the version on a data structure, maybe you say so you version the whole data structure, so you load the old one in, right? And maybe you say you make the rule if they're going to be making changes to the data structures or something, they have to be committed to the main branch before you start making data with it, right? So there's like an agreed upon version of like what data is, right? Yeah, so we did it that way. That could probably change the whole thing quite a bit. But yeah, I think maybe we'll leave that option as something we can look into in the future. Let's just finish off this sketch, I think, because we're kind of diverging from something. Let's see what Nick Volzer said. In both cases, fixed length or variable length, you always save the length. You can give it default names linked to a constant expression. Second case, you can give it a real name field and type from the strut. Oh, so you're saying you always save the length and give it a default named link to, right, I see. So you're saying like, if it's a 7, you always encode it with a 7. Wait. You always... So what you're saying is, if this entity count doesn't exist, you always have... and you just have a 7 there. There's actually always the length encoded in there secretly. That's an interesting take. So you always encode the length of the array in there. In second case, give it a real name. Right. Yeah, that could work. I think that's a good solution. Let me double check what we got going down here. So the other one is like... Oh, right. Part of a constant expression. Right. Oh, so what you're saying is you declare some kind of constant expression thing or whatever, however we want to say it. U32 and you say entities count, and that will just get put into the C code. Yeah, you say 7. So you can actually, so you say you never support. Right. Okay. It's interesting. Yeah, but this doing this explicitly seems a bit. Yeah, I don't think we have to do it this way, but we can always. But I do like the idea of saving it to a file, though. Never think about it. But yeah, having some way of doing a constant expression maybe is a good idea too. Like, or doing a hash define, or however we want to do it, right? We don't have constant expression in C yet. That's C23. So fixed sized array, if that changes, if we did encode the fixed, yeah, we encode it in the data type. So if it changes, if it truncates, we delete the values. If it extends, we initialize with the default values. That seems pretty sensible, right? So truncate. So no, I guess it's just the same thing, right? But where do we do the? But where's the variable length array? But whenever we go from a fixed size to variable length, we need to always store. We need to store this. The fixed sized number in the. Yeah, it gets a little weird, I think. But you know, based on. Yeah. See, we haven't talked about the upgrade functions yet. So if you have an upgrade function, you got to call it in here explicitly. That's another thing. Yeah, we haven't. Yeah. Right. So I think let's visit the field upgrade stuff. So when you upgrade a field, do we stick in this code gen decode function for the structure and say like, well, when we checked the the data that's the reflection data that's stored within the binary file that we're reading and compared it to the compiled data types, we know that there's a difference. So, and we know that, we know they use an older version of entities count, for instance. So maybe you get the versions and you go if. The thing is, you would have written it out there, right? Into that thing. So maybe you actually write it into a, but you already would have read it. So maybe when you say read field, you can say check the versions, and then you'll be able to do an upgrade. But then it starts going into the land of, it's not really code generated code anymore. I want to keep it kind of as code gen as possible, so you can really see it and not really go into this land of typeless, right, where it's like a void pointer and you're going through just type information. It starts to get a little bit, weird, I think. But maybe you have to do it for this because you're still reading the unsized type. So it's like maybe, yeah, Yeah, this is where maybe not part of the struct, just a constant expression. Right, I see. Yeah, I see what you're saying. Maybe. You know what? I think we're quite close with this way, actually. We've only really got to solve this array thing and really iron these guys out, but... And string types, I think they're quite easy, though. But I think we've planned this one out a bit. Why don't we think about the method where we just version the whole data structure and see how much that changes things? Because when you version a whole data structure, it means you could just yeah, when you do upgrades, they can become aware of other fields, and when they're aware of other fields, things just make a lot more sense. So let's just play around with that idea for a minute. So let's do like another example or whatever, right? So let's take that entity thing. So we still might need a lot of what we have, but let's have a bit of a play. So instead what you do is you can still do the aliasing. And you can still do aliasing within these guys. But with structure versions instead. So in here you're going to say this is a v1. Right? But you stored the old v0 somewhere else. So you would then do your sort of v1 to v. Hey, hello Goonies, how's it going? Welcome. So you do your source destination. They'll both be the same data type. Right, both be the same data type. Kind of keeps things a little bit more simple as well. And then you, the user, have to implement this. Right, so you'll go, everything's basically the same, but what I've done is changed. It's all manual at this point, right? The encoding system is more simple, and now the power is given to the programmer to just program it in. And for the most, wait. This would be like a v0, and this be a v1. There will be different types, obviously, maybe. Right, so you'll decode it as a v0, then you upgrade it to the v1. So this kind of leads to some questions in, right? maybe what we do is we say, because this is a very simple version, where we could say, you know what, maybe we don't store any type information in the file. Maybe we just do a complete mem copy of the data structure and just put it in there or something. Or, everything has to retain in the same order. And but then fields have to remain in the same order. So the type information helps you sort of decode the data structure of the order of things change, or if you add or take stuff away, right? And then I think the new version will come in when it comes to being a breaking change. And then that way, so what would be the breaking change? So you can add, remove stuff when you change a data type. When you change a data type, that's a breaking change. That was it, wasn't it? That was in the rules. If you change a data type, there'll be a breaking change. Yeah, and you can say maybe don't upgrade, right? Upgrade none or something if you wanted to say there is no upgrading. So if we did it this way, we wouldn't. The decode stuff would be a lot more simple, right? You would know, like, do I decode? Am I decoding at the same version? Awesome. Just go straight into the file. If not, go into temporary one, and we'll do the whole upgrade chain, right? Yeah, so really just simplify things that way too. That array stuff that was kind of paused on, the problem of that goes away as well. But what it does mean, the cost, is that every single data type that you change, or every single thing you want to preserve, will make you make a new data type that you will have to upgrade. This is the problem with it. And also, if you have sort of branching, am I still out of focus? This is weird. But yeah, if you have this sort of like, version control branching thing where you edit the same entity data structure, for instance, and then so we could probably just have that rule of like, well, if you make a change to the data formats, right, it has to be committed to main before you make any new content that is saved, and we call it some asset, right? So maybe you build you make your changes to this data structure in your branch, for instance. If I was to have more people working on it, then what could happen is they could obviously make their own data and test it out and play around. But then when it comes to sort of like actually saving something, it needs to be committed to the main branch first, and then they're allowed to make content with it, right? So maybe content is only allowed to be made on the main branch, if you will. Yeah, that's interesting. So that would then solve a bunch of problems, because I don't think working on different branches, doing it on the per field basis, is really solving anything. Yeah, I don't think it's really solving anything. So I guess let's keep this thing. But what we're going to do is carry on with the new version. Doing it at a per strut basis, I think. Because this one just feels a little bit too... It just brings in a bunch of little problems, I reckon. So this is like with a per field, versioning, right? Now let's do it per strut versioning. So we're going to have the same sort of thing. We're probably going to have reflection information. But it will be simplified, I reckon. Let's nickel this and just change it. Per field versioning. The example of code gen. With per structure versioning. So instead you will have reflection information because things can be added and removed. Because when you change that data type, that's when you need to provide the upgrades. Yeah. Awesome. That's great, Nagvorza. Thank you. Yeah, it does feel that way. It's a more simplified approach. I did think this way initially, but then I was trying to think about this sort of like branching thing, right? Could we resolve that problem? And I was thinking you'd do it on the per field basis, but I think, yeah, as we just went over, I don't think it's going to work out. It's still going to have the same kind of rules. I think it's a problem that is not solvable without process, basically. But this will be cool. So we'll have the array data type. We'll still do the VLA stuff, and that'll be a change of data type. That stuff is the same. Didn't I keep this? Right, let's redo it again. Right, here's the sort of the rules or whatever, or stuff I have to remember. So a field is never technically removed, it's always remembered by the system. That is correct, until we change the version of the structure. So until the structure so we could say a structure is never technically removed and is remembered by the system. Then we could say a structure field is never for a version of a strut is never removed, never technically removed, and remembered by the system. So when you change the structure version, you can start over again, which is quite nice. Then, so if you change the data type, this is where stuff goes. We have to go right. If you try and change the data type for a strut field data type, the system will error. If if you do this without versioning, and we can say we can also be in like this sort of development mode, maybe. That's another thing we need to think about. Maybe I'm in development mode and I don't have to keep adding new versions. So maybe I could say, yeah. So maybe you could say dev mode, which allows you to you can reset the version back. Yeah, maybe you can run the encoder with a command or something to tell it to restart this version thing. You know, you can run encoder generator dash dash see, restart strut is just a bit of a weird one. Maybe we say maybe you put it in dev mode or whatever. You say dev and you have to remove the devs before you commit or something like this. Hash dev on strut means it will not error. Means it will not keep. Means it will not store a history. That's it. Store a history of that structure, of that new structure version yet. Right, but if it still exists, if the structure exists, then it will error. Something like that, yeah. Version exists and no error. That's cool. So you increment the version for that strut. Either implement the upgrade function in C or do the upgrade none. Flag to say that it's a breaking change. Nothing to do with variable length arrays. Wait, yeah, variable length arrays with different names, not aliased, count as a data type. Change, is that right? I think so. Yeah, we're still doing aliases and stuff. Loading a new version data will result in an error. So now with this change, right? If now we've got the whole structure versioned, this will then mean so I need to get rid of this crap. Now I've got the whole structure that's been versioned. This means that yeah, this means that if we try if we try and load a newer version, it's a lot easier to detect that rather than it being per field or something. No, I think it was the same thing actually, because you only need to do a new version if you change the data type. And if you change the field data type, it would have still happened. Okay, maybe not. 0 is the default value and I specified explicitly. Yep, we'll still keep that. Default values are not stored. A binary file will contain a bit set of which fields are not the default value. And then we say the latest we always use the default value from the latest version. Let's just do that. Cool. 5 other encoder generated data types and arrays cannot have default values themselves. Yes. So that means if we have an array of some other encoded type, that can't be a default value. But we can say have a default value of some other structures that are outside the system. When we decode a strut, right, this is different now. So I think I'll just rethink this. I'll delete it. And we'll do it in the example code below. Variable length arrays field with its count must come. Nope, that's gone. Binary files only store the hashes in the type info. Yep, still stays. We do not support renaming, but we support editing. Yep. Yeah, cool. So let's do this thing again. So array type. So I think this still stays the same. We still have the variable length array thing, right? And 0 means use the variable length array. It's the VLA. Type. Where's the strut one gone? Right, I don't think I copied everything I wanted. Right, so the type kind's fine. Strut field, type and version. Sure. See, we can't have specific offsets because we have the optional field thing. We're still doing aliases, so we want to be able to remap an enum to some field index. So this probably all stays the same, to be fair. Yes, it's just the decode code is different. So I still think we'll do the validation the same. We'll just, look for aliases and work out, work on those maps. But the decode is where it becomes different. So we've now got these sort of V1, V2 structures and things. So we could just start with if statements and just go, well, this could be decode V1, right? But then we've got a V. So what you do is you say if. So we know we're going to want to decode a V1. But then we go if source type version, and that's something we're missing. The version is not on the field anymore. It's on the strut. And you can't version arrays. Version struts there, cool. So this field is really just types. Why is your C compiler compiling what you don't want? Huh? What do you mean? We're not writing out C code right now. We're just planning something. I'm not sure what you're referring to. Hey, Prez, welcome. Default init versus given values is a version changing. Oh, that's an interesting one. Yeah, it's an interesting one. Default value versus given values. So are you talking about change? So just to be clear, you're talking about changing this. So if I say default health is 100, and then I go, hang on a minute, it's now 700. Is that what you're saying? Does it need a version change? Yes, we'll probably want the type. Whoops. Yes, I don't think we have a strut field anymore. We have a strut types. So what are you saying with a field exists? You can get a field index back or something? Something like that. Yeah, then put in the field. So you're trying to build the new map. So that'll be source type, field types. Well, it's a field index remap, isn't it? You're building a few things. Yeah, okay, cool. Right, so that's the validation step. It's got a bunch of missing stuff, but it's the same sort of idea. We're still going to maybe use these enum things. Because we've got renames. So you have a V0 decode, and you have a V1 decode. Right, so you've got explicit versions like this. Then so basically this will do the V01, and then the V1 is going to say if the version is equal to 0, then load 0. And I guess it will just keep, you know, if you're on a V2, it will say if you're on a V1, and then we'll just recursively call those functions, and then come back up again. Should be all right. And so that'll load you a V, or will it? Yeah, because I think the logic is we want to say we're decoding a V1, and so we'll put a breakpoint in there, and then we can just follow it. But I think this is an early return, because I think this is going to do a level, so it'll call this one, and then it will call, so decoder, source type, then you'll put this on the stack, level enc v0 v, and then you call the upgrade thing, which the user should have provided. That's the upgrade, but if it's a no upgrade, then you do nothing, right? You just return the default value. So we should remember that quick. Yes, this is an entity one. Right, but level encoded data. Then you pass in your out and then v. Right, so we'll do that. And then we'll return. Now there's another version of this where if you don't do any upgrades, but if it's version 0 and you've said, you know what, we're restarting from scratch again, well, it's just going to load the default value and then it's just going to return. Yeah, so those are the two possibilities that can happen in the code gen. From default to given values, it should be a version change. All right, let's think about that one. Right, so if they've put their data in and it should be a version change. So you read the file, it's got health, it's always got a value, you read the value, you put it in, right? Why should it be a version change? And if you remove the default value, because there's already a default value, the way that I'm thinking about it, there's always, the default value is always 0. So this is just an explicit default value. You're saying that it's now 100. So how will we do this kind of decoding thing now? So I think we'll do... So you want to read the decoder, the source type of the structure that you're looking for. This thing... Yeah, do we keep that? I think so. Yeah, I think this all stays the same, basically. I think so. So is it like a binary decode? Yeah, it all works very much the same as we described earlier, right? It's got the offsets that it has to scan through to find where the offset is stored, read the data out. Okay. Yeah, I think this version is good. I think I want to stick with this one over the other one. I think, so we still have a bit of time today. I think we should try and think about the bit packing. I'll keep the old one around just in case. But I think we're going to stick with the versions. So yeah, I think this is pretty solid, and we can probably next stream get started on actually writing a little parser, parsing the stuff, and work on actually generating some code for things. I think it's all pretty thought out now. My one concern, well, we didn't do string types, but yeah, we can do strings. Well, they're just char arrays, right? We could support my core string thing. Yeah, I think we'll just support my core string data type, and we will support char arrays. Yes, that's how we'll support strings. Maybe. Well, this is a data format. Maybe it's just char arrays. So you just put the count in separately. Yeah, I think that's okay. Arrays of bytes. That'd be fine. Right, so that's pretty cool. So the other thing we wanted to think about is that sort of like bit packing and stuff, because this is probably great for like, this is great for writing to a file in binary, but like networking, which I want to use it for networking as well, we could probably really pack stuff down a little bit more. So I was initially thinking like, well, it's great because if you just use these types, you can just read them out as they are. But we've gone and added a few little things. I think we added this bit set thing, didn't we? Yeah, we've added this bit set. So every structure has a bit set that comes before. I'm sure I'm at the right place. Field versioning, no. Yep, this is it. So, so basically when we encode a data structure out, we have a size for the number of, like a bit set basically. So it might be a U16, it might be a U8, it might be a U32. But if say it's a U8, because it probably is most of the time, if you haven't got a lot of fields, you can support 8 fields there to say which ones are not their default values. Oh shoot, did we fix that? Yeah, this should always be instantiated with the default value. If the upgrade, I know that does not really make sense, but there you go. Yes, if we have version upgrade support, we do that. If not, we just return with the default value. Yep. Okay. Maybe there's a way to programmatically generate the entity of a function, but I don't think I need that yet, so we won't do it. Okay, what are we doing? Right, we was doing the bit packing thing. So when you use a U8 at the start of the data structure, well, guess what you've gone and done? If you want to read out a full U32, you've got to put a lovely bit of padding in there. Right, 3 of those guys. Let's do the Rust syntax, you know. Yay, Rust. You've got to put like 3 bytes of padding in there. Let's not do Rust. Anyway. Before you end up getting your value that you're trying to read out. So this one exists, and this one is the I don't know what it is. Maybe it's the scale, right? So it's a float. So in this binary serializer, we're putting little bits of padding bytes in there for alignment and things. But we're able to completely miss out fields as well. Because if they're their default value, then they simply won't exist. So this means when we're reading over the file, simply calculating the offsets for things will be based on sizes and aligns, and it'd be quite weird. So maybe by bit packing stuff down, if we just bit pack everything down, we won't have to worry about doing alignment, and it will just make things better. Yeah, so I guess we could just do as another one, right? The binary serializer, or the binary encoder, is bit packed. So it makes alignment easier. So there is no aligning code and is, and has no padding bytes. But it does come at the cost of maybe taking, you'll have a field which goes over 2 integers that you've read. Maybe we read 8 bytes at a time and it goes over the 8-byte boundary. So you have to read another 8 bytes and then start shifting stuff around. But that's okay. So now that we have settled that we're doing that, basically supporting a more thorough packing scheme is probably, making some more sort of distinct types for like packing these integers down into the least amount of bits is probably a wise idea to figure out. So let's just have a bit of a play around with that one. So we did have that hash hex thing, which is for the text encoder to say, hey, we want this in hexadecimal. But really, we could make it part of the data type, basically. So we could say like hex 8 instead, like that, or h8, I don't know. And maybe these are like uint. But if we did this, it could be quite awesome that we say, you know what, we only support a value between, maybe like maybe as part there's like a validation process or something. No, but that's what the checksum is for. The checksum will just tell you if it's invalid. I was thinking maybe we could support some sort of ranges of integers, and maybe you could do some offsets and stuff. Maybe you could maybe we could have the system automate doing float packing. I think for integers it's probably not that useful, but we could think about it still. But the real use is for floats, right? Say if you have this scale, it's a float. And you want to decode it into that float, which would be nice. But really what you want it to actually be is a U8 in the file, or maybe only takes 7 bits or whatever it is. But so maybe you call it like, in textures on GPUs, they've already got this thing called unorm. So you just call it unorm, right? But maybe you've got it's not really unorm that you want it stored as. What you want it stored as is probably you might want a different range. So if I said a range from, maybe I could say store as EU8 for me, please, but I would like a range from minus 0.5 to 0.5 for some reason. Right, a bit of a weird thing, but that's what I need for my type. So we can do that. And then it will automatically pack it down to a U8 and then pack it back up. So this means we could then support the 7-bit integer or the 6-bit integer for the packing, right? That'd be quite interesting. So then if you're doing this for floats, maybe you could consolidate that down into a specific type with some kind of like alias or something, or maybe you call it a your own float type. Maybe you say float. Or type def. And then you do your sort of f whatever, right? So take a bit of parsing, but it's alright. We can work this stuff out. So you do all your stuff, blah, 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 blah. And then you call it. So this will just be part of the code generation system. And you can give it a name. It's just a short little alias. You'll call it a I don't know. Because you might repeat many times, right? So you could probably do that. So for integers, does it make sense to have this sort of ranginess about them? Well, it might do, right? Maybe you say, you know what, bring it up as a U32, but store it as a U8 or a U16. Because what I want to do is actually have a value from. So I'm not sure if this will make too much sense. Maybe say I want it as a U16, but maybe health can never, okay. Or maybe go, maybe it's better with strength, right? Strength is a U16 when I read it, but when I store it, I actually want it as a U8. Between the range of, maybe you can never have a strength lower than 100. But what I actually want is a strength going up to, I don't know, 300 or something, right? And that's 200 range, which fits into a U8, but it doesn't, and it automatically does the offset and stuff in the encoding, because we're around the code generator. So it's automatically doing the adding and whatever to sort of in the decoding phase. So maybe it could be less error prone when encoding and decoding these things. Potentially. Yeah, that's maybe the idea that we could do with this bit packing. So the float one is definitely useful. Because I could see that going all over the place for like packing floats and things down over the network or something. Definitely a big one. The creator of protobuf created a faster bin. Format, I don't remember the name, but has a blog about this exact stuff. Interesting. Is it the is it just reflected in the it's already bit fills though, is it? Optional, don't want to support that. They got variable int types as well. So they got fixed point. Yeah, it might be interesting to do fixed point as well. It's a good one. Maybe you could say FP. We definitely did not think about that. But yeah, maybe you could do another one called like FP. You'd have to do. Wait, is that a fixed point or am I misreading that? What does fixed mean? So I was saying what fixed is. But yeah, if you can find a link for that neg4s, that'd be excellent. It'd be great to take a look at that. But yeah, that's interesting. Maybe I should look at Protobuf for a bit of a inspiration, maybe. But yeah, they've got this in Protobuf thing called like a fixed. Well, what is that? Is that a fixed point value? Because fixed point does make sense for packing stuff. Always 4 bytes, more efficient than U32 values are greater than. Why? What is it then? Because 2 to the power of 28 is still representable in U32. Oh, it's it's a variable length int. They support variable length ints, right? Right, so that's interesting. So when they're encoding the data out, then they're looking at how big the value is and maybe storing information alongside it to help decode it and store less. But that feels like you really got to know. Oh, so he created a new one after he probably left Google or whatever it is, right? Neat. Is that the guy who's got the game engine with the voxels, the voxel game engine? Is that guy? Or is that flat buffers? There's a different one. Yeah. I always get confused with them because I've not really used them. But yeah, maybe we should have a fixed point type as well. Because the fixed point would then mean we could pack things. So we can maybe say, hey, take this float, put it into a fixed point value, and then unfixed point it, right? At runtime. So maybe we could say, there's another example of like, hey, do fixed point 6 point, so 6.11, so these are 6 bits for the integer part, 11 bits for the fractional part. Could be interesting. But then like, I guess you would say, so signed and unsigned, what would you do? You maybe use 1 bit for the signed bit, but so maybe you need like a U and an S. Yeah, I'll think about it when I implement it. Huh. So like Captain Proto. Right, Savaganda. Yeah, it's usually two's complement. Yeah. Yeah, that's right. It's not a decimal place. Both of them are. The integer and fractional part are two's complement. Yep. But doesn't mean the encoding format must be platform specific. No. Yes, however, all these extra bytes are zeros when. Ah. We. Oh, so these in fixed size inches. Oh, so they're not doing the variable sized int thing anymore. I should stop reading like a Gen Z and skipping things. Gets a perfect score because there's no encoding and decoding step. Bum bum bum. Whereas encoding is appropriate both as a data. Once the structure is built, you simply write the byte straight out to disk. Funny. That's what we wanted to avoid, right? Because we wanted to pack it. So I think this one's saying like, nah, just compress it and chuck it down the wire. You know, I don't think this is. I think this. So like, obviously it's faster, right? Congratulations, you've just made. You know, you've made one trade-off for another trade-off, right? Basically. How does one learn to create games without an engine? There's many places. Um, you know, I reckon you should get started with maybe SDL 3, maybe. Have you seen SDL 3 lately? Have you heard of SDL 2? So SDL 3 is the next version. It's mostly the same, I think. Not to dwindle the upgrading stuff that they've been doing, but they've added a new GPU layer. So this means you can write a renderer with their GPU API, and it should work across Windows, Linux, Metal, and other platforms too. But yeah, Handmade Hero is another good source. Highly recommend. But yeah, I recommend getting started with SDL, and you know, or if you're very beginner C programming still, get started with Raylib and learn C through Raylib. Raylib's got a very simple API, and they've got tons of examples and things on like how to set up a window and how to get a simple game going or a little 3D camera. I wouldn't do 3D, start with 2D obviously, but there's a little 2D platformer and you can test it in here, and all the code is here to copy and paste into a C file and get going. So, and in Java, you could do it in Java if you want, but you know, It doesn't mean the encoding is platform specific. No. Predefined byte dependent. However, it's designed to be efficiently manipulated in common. Data is arranged like a compiler would arrange a strut with fixed widths, fixed offsets, proper alignment. Variable sized elements are embedded as pointers. Pointers are offset based rather than absolute. So what about this little endian thing, right? Integers use little endian because most CPUs are little endian. Even big endian CPUs usually have instructions to read little endian data. I don't get how it solves the big endian problem, but we don't really have big endian CPUs anyway. No, new fields will be added to the end of the strut or replaced in padding space. So existing field positions are unchanged. The recipient simply needs to do bounds check when reading a field. Fields are numbered in orders which they are added. So Captain Proto always knows how to arrange them for backwards compatibility. So you're not simply mem copying everything. You're mem copying portions of things. Right, so if you remove stuff, what happens? That just spoke about new fields. So you never remove fields. Won't fix inches, unset optional fields be a waste of space. See that unset, so those fixed with integer things. I get, oh yeah, they did that run length thing where they say the first 3 bits tell you. It's a bit like UTF-8, I think. The first number of bits will tell you like how many bytes there are, and then you take those bytes and right. Yeah, that's another encoding scheme that could be used. Right, so we'll compress standard structures. So it still validates the data. I still don't get how it deals with removed things. Like, you don't remove things then. Cheap viewers. Oh. Yeah, the thing ain't working, is it? I need to just phrase viewers on. Yeah, you can use Java if you fancy, but I recommend learning C and things because Java's got like a garbage collector, and then like you'll produce a ton of garbage, and then like it will have to garbage collect, and then your frame time will hitch. But you can get around that in Java by pre-allocating arrays and managing your own memory. But then you might as well just be using a lower level language. Yes, this is interesting. I don't know if I like this idea, but it's interesting. So incremental reads is easy to start processing prototype messages before Captain Proto messages before you have received all of it, since outer objects appear entirely before inner objects, as opposed to most encodings where inner objects encompass the outer objects. Not sure if I understand that one. Random access, you can just read one field of a message without parsing the whole thing. I guess. But you still have to skip your arrays based on a variable size that you've got from somewhere else. So calculating that offset takes a bit of magic. mmap. Okay. Call C++ code from Java, which tends to be painful, slow. We've kept in whatever. Two languages can implement the same structure. Fair play. It's not a problem for us. There's also Odin as well as another language. That could be easier to come from like Java, maybe. So arena allocator. Okay. You can arena allocate other things. Tiny code generated. Yeah, I feel like this is like trying to do like the memcopy approach, but then not being able to do the memcopy approach. Yeah, like extending the memcopy approach by putting the new fields after the old structure, but then you still have to, know the type information to skip past the extra bits you don't need or something. I don't know. Wait a minute. Yeah, you should never be loading newer data. You should always be loading right, I see. So you'll like have your strut. Let's write it out. So you'll have your strut, something. So the way this one works is like, you have, this is your value 1, and then say that's your version 1. Then when you did a version 2, you'll put 2 on there. You put a version 2 on there, and then version 3 adds field 3. So basically you'd always only load it if your version number is newer than the saved one. So if you've only got version 1, you basically like get the something structure, only read out field 1, but the rest won't be read. Yeah. And then you're not allowed to reorder the fields, and you're not allowed to delete fields. You can only just add fields. And then you've just got a bunch of padding and things aren't really quantized anymore. So things won't be packed. And then they do a compression step on top of that. So what's kind of interesting is they go, hey, the encoding has gone from 156 microops or whatever that is to 0 microops, failing to mention that they run, well, they mention it down here, but in this graph where they're selling you on it, they're failing to mention that they run a compressor on it afterwards. Right. So when they say when the bandwidth actually matters, you run a compressor on it, and that takes some time. So I think it will be quicker to write out the file in protobuf. Like, okay, I'm not sure how protobuf works, and it's called the variable length integers. But if you just to bit pack everything and write it out, is that quicker than running a compressor on it? I think so. I've not measured it, but I think it is. So I think this is this could be potentially the same cost or slower. I don't think, like, if you run the compressor, basically. Yeah, it's got some interesting ideas though, right? It's the evolution of the memcopy. But yeah, interesting though. Yeah, I don't think that's what you were referring to, Negvorza, though, because you was talking about the packing stuff. Maybe it's flat buffers. Okay, so flat buffers is made by Google. So I forgot what protobuf was made by. Anyway, yeah. So maybe we support that variable int thing. I don't know if it's really a good, you know. If we support the variable int thing, it's going to mess up our skipping code because our skipping code is going to know if it exists or not. Actually, no. We don't have skipping code anymore. We simply just have an array of bytes. So maybe we could do that variable int thing. You could just say a variable int. Yeah, we could probably support that too. I don't know. Yeah, the reduction thing. I remember you saying that. Yeah, that's cool. But it's good to read about it nevertheless. But yeah, it's funny how people make software and then they go, look at all the amazing things it does, and then never talk about the bad thing. Or like they say, here's the new speed improvement. It beats it at this metric. But what about the other metrics you've just added to? You know, it's a bit weird. People are weird. Yeah, maybe we support the variable int thing. So you basically just store the bits at the front and say it takes. You read. Yeah, I'd have to look at that var. Like, how does it do it again? I remember seeing this a long time ago. The var-int encoding. I forget. It was dead simple. Um. Huh. Mm. So there's 6 wire types. The tag of the record is identified with the var-int formed from the field number. The rest tells us. The integer tells us the field number. Because the wire type is 0 or var in, we know we need to decode the var int to get to the payload. As we saw, the bytes to 150, giving us our record. Huh? Variable length or variable width, integers or var ints, the core of the wire format. They allow encoding 64-bit ints using anywhere between 1 and 10 bytes. Right. So they round up to bytes. So it's not with bits. So each byte of a var int is a continuation bit. Yeah, it's the continuation bit, a bit like in UTF-8 or something like that. It's got the continuation bit and it reads a byte. Yeah, maybe we won't really support that because we could just pack it manually, I think. But it's an interesting idea at least. Time for bed. That's cool, man. Good to see you, Driver State. See you in the future one. Right, so I think we're in a good place today. I think we've discussed, found out what we want to do, thought about a lot of problems and solved a lot of problems. So I guess in the next stream, there might be one or two things where I think about that we need to fix, but I think we're all good. So I think in the next stream, we'll start off by maybe just finalizing on this bit thing, bit packing thing, just clean it up a bit. And then we'll go ahead and get a parser written up. So we'll parse up all of the, all the structure stuff. And, I'll probably write like a proper Lexa this time, because last time I used like a text reader. This time I'll do a proper Lexa, and we'll just parse up the file and produce some structures with the data, and then we'll start to generate some code in a future stream some other time. But yeah, thank you all for coming, guys. It's good to see you. Our next be on Tuesday, 6:30 p.m. GMT +1. You can come and hang around in the Discord channel and hang around and talk off stream. Yeah, Tuesday and Thursday and Sundays. You can check the timeline on Twitch to find out the exact times. I need to eat some food and go to bed. No worries. Thank you, guys. Thank you, guys. Do I see a bit of funk? This is go, innit? Right. Go have a good time, guys. And have a good start to your work week. I'll see you on the future one. Thank you, thank you, thank you, thank you. Bye-bye.